Okay, welcome back to the Sun Lab part, whatever we're on, with all these videos. Thanks for sticking with me. I know it's a lot, but smaller videos, more of them, I think, is better than one big long one. So let's do it. The speed of the sun. We want to figure out now how quickly is the sun moving across the sky. But of course, like we said earlier, the sun's not actually moving over our heads. We are rotating underneath the sun. So if we measure the speed of the sun, we're not really measuring the speed of the sun. We're measuring the speed of our own rotation, which is kind of neat. I mean, with these two cheapo pieces of plastic and a piece of cardboard from a dryer or something, you're figuring out the speed that the Earth is rotating, which I don't know. It's impressive. It's kind of neat. We can't do it in miles per hour. That's a lot harder. We need Google Earth for that, but we can do it in degrees per hour. And the correct answer to this, we're going to see how close you get. I've had people get it right on the money many times. There's usually very low percent error on these. Um, but the correct answer, which you're going to figure out right here, is a really important number here in earth science. So you're going to want to stick that one in your head once you figure it out, or be able to solve for that anytime. We talked about that on one of the classworks already, and you'll do it again here, and hopefully we'll get that number down. So let's do it. Once again, there will be a line when you guys have to do this. I haven't drawn it yet. And you're going to take measurements along the sun's path using those X's that are there. So for periods 2, 3, 4, 7, 8, 9, you're going to measure in between to figure out how quickly the sun is moving. You'll need the times that we took these readings. And like I promised, I would forget one of these. I forgot to write down what time we did at third period, so don't do it for the third period X. Choose two others. So why don't you start by choosing two? I want to measure between this one and this one. Choose two. Do that now. And maybe draw a little line. Like if you want to go between second and seventh, do that. I'm not going to solve any of them because you might all pick different ones. Just again, don't pick third. And all we really got to do is get an answer in degrees per hour. So the two things we need, and here's the setup, please do it, is you're going to divide degrees by hours. So we need some number of degrees. How many degrees pass in between those 2 points that you chose, and how many hours pass between those 2 points that you chose? That's going to get slightly tricky, but we're smart folks. We're going to figure it out. So procedure wise, for the degrees, what you're going to want to do is take this compass, take the 0 again. Now, all measurements now, like it mentions right here, are along the sun's path. You're not going from the cardboard up anymore. We're done with that. Now you're going to go right along the line that, again, will be drawn on the thing by the time you get it. So what periods did you pick? Did you pick that one and that one? If so, put the 0 on the first one and go to the second one and see how many degrees it has traveled in the meantime using that external protractor. Okay, it went from that X to that X. That's blah, blah, blah number of degrees. You tell me. And you might all have different answers because you're all going to pick different points. So that's going to give you some number right here. Next, hours. How much time passes from one to the next? This is where life is going to get a little bit tricky because not only do we need to be able to calculate that and figure it out, and again, a calculator itself is useless because a calculator doesn't know that you're talking about time, which repeats every like 60 minutes. It goes to a new hour. Your calculator doesn't know that. So you can either use the time calculator from the internet, just type in time calculator in Google, or maybe I'll try to put a link in. Or you could just start, think about trying to figure it out because we're going to have to figure these things out eventually. When we do marking period 4, when we do earthquakes, you're going to have to be able to figure out time, doing arithmetic with time. So maybe today's not a bad day to start. How much time passes from this to this? You can just count. So if I need 9:55 up to this, okay, I need 5 minutes to get to 10, and then it's this many hours, and then how many more minutes? That's a good way to do it. The one problem being that since we're going to be dividing, we need that as a decimal. So let's say, here's a good format for figuring that out. You're going to have some number of hours and some number of minutes. Let's think about what that really means, though. How many minutes? A minute is really like a fraction, considering that there are 60 minutes in an hour. Let's say that ended up being 30, like 2 hours and 30 minutes, which none of those will. But let's pretend it did. If it was like 2 hours and 30 minutes, that's like 2 hours and 30/60ths of the next hour. And 30 over 60 is a half, 3 over 6. So that would be 2.5 hours. That you could put over there, that you can throw into a calculator. But if you go over here and write 2 hours and 30 minutes, you're not going to be able to take this and divide it by 2 hours and 30 minutes. It's just not going to work. So don't do it. And in fact, 2 hours and 30 minutes shouldn't appear anywhere on your lab because that's not going to be the right answer between any of these. But you can use this format if you want. It's this many hours and that many minutes out of 60 out of the next one. And then type in your calculator, and I'll just show you for the heck of it. Let's say it was 17 minutes. I don't know. 17 minutes. So why don't I write it so that you see it? If your answer ended up being 17 minutes, which again it is unlikely because I just made that up. If it was 17/60ths of the next hour, that would be 0.28. So it'd be however many hours, 0.28. Not simple, but doable. All right. If you're stumped, let's talk. We'll try to figure it out. But use that as a format. Cool. We know the Earth rotates 360 degrees in 24 hours. So what should the answer end up being? Do the same thing. How many degrees over how many hours? Only this one's going to be a lot easier. 360 degrees over 24 hours equals, you tell me. And that answer, put it in a big box and then put it into your brain because it's going to show up and it's going to show up and it's going to show up. And then how close did you get? Once you're there, you have made it through the work for the hardest lab of the year. Maybe. There may be a few others that are pretty difficult, but this is up there as a very tricky one. I am going to have a few more pages with some questions because how am I not myself? But thanks for making it this far. Thanks for sitting through all these videos. Great job. And hey, Marking Period 1 labs are all done. Congratulations. A quarter of the way there. Farewell.